to sketch a little graph. And remember, when I ask you to sketch a graph, it doesn't have to be like a work of art. It just needs to be readable and clear. So I want to make sure that I can tell where your points are. So something like this, that's good enough. It didn't take me 5 minutes to lay it out, but it's easy to read, it's clear. So I'm going to plot the points -2, so backwards 2 and then up 3, so -2, 3. That would be up there. And then 1, -1. 1 in the x direction, -1 in the y direction. So there's my other points. I'm going to connect them with a line. That's the distance that I want to find right there. So Pythagorean theorem, of course I make this into a right triangle, and then I figure out how long each side is. So how long is this vertical side? Help me out, I'm not good at counting. 4? Okay, I believe you. How long is this horizontal side? 3. Okay. Ooh. I know this without having to do the Pythagorean theorem. But let's work through it real quickly. So the Pythagorean theorem, we're going to say 3 squared plus 4 squared equals blank squared. So I'm going to call that distance d because it's the letter that distance starts with. So there's the Pythagorean theorem. So I'm going to square each of those, 9, 16. Then I'm going to add them together. So what's that, 25? And what's my last step in the Pythagorean theorem? Yeah, the inverse of squaring something is a square root. So I square root both sides. And when I square root d squared, of course, those cancel, and I just get d. Now, yesterday I had you leave some square roots as square roots, like the square root of 20, because they didn't have nice, pretty simplifications. What about the square root of 25? Yeah, that's 5. So if it's a whole number, just go ahead and take the square root. Because 5 is the exact answer. It's not rounded. Okay. So that's A. Any questions there? Let's try B. So on A, I said we make a right triangle, we figure out how long each side is, then do the Pythagorean theorem. For the distance formula, we make a right triangle, figure out how long each side is, and then use the Pythagorean theorem. Remember, it's the exact same thing, only with the distance formula, you figure out how long the sides are by subtracting. So remember we did something like this. So we said the run, here's the run squared, plus the rise squared equals the distance squared. So we may not have written it exactly like that in the notes. But when I talk about the run, I'm talking about that x distance. So that's the difference in the x values. And when I talk about the rise, that's the difference in the y values. And it's just the Pythagorean theorem, written with the individual point values in it. Okay, so let's plug in some numbers. How far apart are my x values? Well, to figure that out, I subtract them. So I might do 1 minus -2. And it doesn't matter which order I do it, as long as I do the x's and the y's in the same order. So I'm going to say 1 minus -2, or 1 plus 2. And the difference in the y's, again, I'm going to go in the same order. So I started with 1 and then -2. I've got to do -1 minus 3. Not a comma. -1 minus 3. And I'm going to square that. And that's equal to the distance squared. So this may not be the exact way you wrote the distance formula last year. This is the way I usually write it because it makes the most sense. It's just the Pythagorean theorem. It's the same thing. So 1 plus 2 is 3, so 3 squared, plus -1 minus 3 is -4 squared. Now this looks almost exactly the same as the first step of the Pythagorean theorem, right? What's the difference? You see the difference? Yeah. This is negative instead of positive. But what happens when we square that? Yeah. So 9 plus 16, that's going to be positive. And I want you to be careful when you type this into your calculator for official math purposes. So if you type in -4 squared, like that, what do you think it's going to tell me? Is it going to say 16? Yeah, it's going to say -16. Well, I thought -4 squared was +16. So how do I have to type it in? Yeah, you could do it a couple of different ways. You could do just -4 times -4. That would work. Or if you're going to use the squared, make sure you put that -4 in parentheses. So -4 all squared, -16. Just the way we wrote it right there. And so from here, it's the same as the algebra up there. So we add those together, we get 5, take the square root. 25, sorry, and take the square root, which is 5. Okay, so there's B, and let's look at C. So C is maybe the part that you had a little bit more trouble remembering from the first lesson. So let's recall what that looks like. So here I want to find the equation of the line that goes through these 2 points, and I want to find it in point-slope form. So what information do I need to use point-slope form? Exactly. I need a point, and I need the slope. Do I have a point that the line goes through? Yeah, I've got 2 of them. Okay, so I've got a point. Do I have the slope? Not yet. Could I find the slope? I hope so. So remember, the slope, just like the distance formula, also involves the rise and the run. So the slope is the rise over the run. Some of us tried to find the distance using this formula on the first day. So the rise, again, is the difference in the y values, and the run is the difference in the x values. So let's find that first. So the difference in the 2 y values, it's going to be these same two numbers in here. So it's -1 minus 3, or you can flip it. And then the x's on the bottom would be 1 minus -2, so 1 plus 2. And just like in the distance formula, as long as you're consistent with the order you put the numbers in, it doesn't matter which one is y2 and y1, x2 and x1. So that's -4 over 3. And you can type this in your calculator. It'll tell you -1.33233333. But again, we don't want an estimate. We want the exact value. We want to leave it as a fraction here. And now we're going to take that and plug that into point-slope form of the equation of a line. So that -4/3, that's the slope, is going to go in for m. And we said we were going to use a point. Which point do you want to use? -2, 3. An excellent choice, just as good as the other choice. Now, this would be, and the x value, this would be the y value. Do they go in for x and y, or for x1 and y1? Yeah, for x1 and y1. Remember these, what I called naked variables? They don't have any subscripts. You don't plug in numbers there. You plug them in where you have subscripts. That's true here and also in the distance formula. So the y1 would be the y value there, that's the 3. The x1 would be the -2. And the y and the x stay like they are. So we've got y minus 3 equals -4/3. Sorry, I'll get back on the screen here. -4/3. And then we could go ahead and write that as x plus 2. And are we done? Do we need to solve for y? So what did the question ask for again? Find the equation in point-slope form. Do we have that? Yeah. So this is the equation of the line. Remember, you don't have to write the equation of the line in slope-intercept form, unless, of course, that's what I asked for. It can be written in multiple different ways. This is one of the ways. It's not the one that looks the prettiest, but it is informative. It tells you the slope and tells you a point that the line goes to. Okay, so any questions about that stuff? Feel ready for a quiz on it?